Now we're going to do the inverse calculation of what we just did. Given the pH, we want to be able to calculate the hydronium ion concentration. In words, we take the antilog of the negative of the pH. When we say antilog, we mean 10 to the power of the number we are taking the antilog of. Here you see how we calculate the hydronium ion concentration for a solution with pH 4.75. I will now show you how to do this in the calculator. On most calculators, the command we want is right above the log command. So we're going to go ahead and press second and then log to give us 10 to the power. This is called the antilog. We now type in negative of the pH and hit enter or equals to get our answer, which in this case is 1.8 times 10 to the minus 5. Be sure not to forget the e minus 5 at the end. As before, I would like you to pause this video and calculate the hydronium ion concentrations for the three solutions below given their pH. When you are done, unpause the video to see the answers. I begin by pushing second log to get the antilog command, then push the negative button followed by 3.0, and that gives me 0.001 for the first answer. For question B, I again push second log to get the antilog, negative 12.5, and this will give me a very small number, 3.16 times 10 to the minus 13. Again, be sure to notice the 10 to the minus 13 at the end. For the next problem, I again click second log to get the antilog, then negative 0.95, and this gives me a very acidic pH of 0.11. For aqueous solutions at room temperature, there is an important relationship between the concentrations of hydronium ions and hydroxide ions. The product of the concentrations of hydronium and hydroxide ions must always equal 1.0 times 10 to the negative 14. This number is a fundamental constant that we call Kw. It turns out that when water is left to sit, a very small number of water molecules will react with other water molecules. The two water molecules react to form a single hydronium ion and a single hydroxide ion. What is the concentration of hydronium ion for pure water? Pure water is neutral with a pH of 7. As we saw a few slides ago, the concentration of hydronium ion would then be 1.0 times 10 to the negative 7. What is the concentration of hydroxide ion for pure water? We can just use the equation for Kw to find this value. Dividing 1.0 times 10 to the negative 14 by 1.0 times 10 to the negative 7 gives you 1.0 times 10 to the negative 7. Does it make sense that the two concentrations are the same? Sure it does. The solution is neutral, and that means the concentrations of the two must be the same. Will the two values be equal at any other pH? No. Acidic solutions will always have a greater concentration of hydronium than hydroxide. The opposite is true for basic solutions. For practice, complete the table shown here. For each row, calculate the values which belong in the missing boxes. Next, in the column on the right, indicate whether the solution is acidic, basic, or neutral. Note that this kind of problem is very useful not only for answering questions in this lab, but often for answering exam questions as well. Please pause the video, copy this table onto a sheet of paper, then carry out the necessary calculations. When you are done, unpause the video to see the solutions. So let's take a look at solving for the values that are missing in the table. We first identify that on the first row the pH is 2.55. Using that information, we will want to find the hydronium ion concentration. The hydronium ion concentration is the key to finding all the remaining values in the table. To find the hydronium ion concentration, we just take the antilog of the pH, 10 to the negative 2.55. Entering this in our calculator will give us the correct answer. The hydronium ion concentration is 2.82 times 10 to the minus 3 molar. We can find the hydroxide ion concentration from the expression which we just learned that states that the product of the hydronium ion concentration and the hydroxide must equal Kw, 1.0 times 10 to the negative 14. Rearranging that equation, we see that the hydroxide ion concentration equals 1.0 times 10 to the minus 14 divided by the hydronium ion concentration. We substitute in the value we just found for the hydronium ion concentration and solve. Giving us a solution of 3.55 times 10 to the minus 12 molar. And here I just fill those values into the table, making sure to remember the units of molarity. We look at the pH to determine whether or not the solution is acidic, basic, or neutral. And since 2.55 is less than 7, this means the solution will be acidic. In row 2, we are given the hydronium ion concentration. Let's use that first to find the pH. The pH is the negative log of the hydronium ion concentration. Upon entering the values into our calculator, we find a pH of 2.19. To find the hydroxide ion concentration, we use the exact same procedure as we did in the first row. taking Kw and dividing it by the hydronium ion concentration. Using our calculator, we find that the molarity of hydroxide ion is 1.54 times 10 to the minus 12 molar. All that remains is to determine whether the solution is acidic, basic, or neutral. Again, we see that the pH is less than 7, indicating that this is an acidic solution. In row 3, we are given the hydroxide ion concentration. To find the hydronium ion concentration, we take Kw, 1.0 times 10 to the negative 14, and divide it by the hydroxide ion concentration. Solving in the calculator gives an answer of 2.22 times 10 to the negative 13 molar. Now that we know the hydronium ion concentration, we can find the pH. The pH is simply negative log of the hydronium ion concentration. In this problem, the pH is 12.65. We fill those values into the table. Here we see that 12.65 is much larger than 7, indicating that the solution is basic.